Hi everybody. Today we are going to use time series data, and we use the method of ordinary least square. And now let's look to datas. Open the Excel file. You see that our period is starting from 1920 and up to 2019, and at the starting point, we have y dependent variable and x independent variable. So how can we open this Excel file in Views? Now right click on this Excel file and say open with Views. It's not important to use Views 12 and 10 or 9, whatever. You can use whatever you want. I have Views 12, so I am opening with Views 12. Now you see that Views open this Excel file and say next. And this header line means if we choose header line as zero, you see that first line is going to be the names. So we have to choose header line 1. So we put the names on the first row, first line. So the others are the values of the dependent and independent variables. Next, say next, and you see that you can easily understand that our frequency is annual. So also the values are regularly given. So it says dated, specified by date series, and say finish. And also you can use as no. We are not going to import for giving link for the external source, for any external source. First of all, for the time series, we have to look the graph of our dependent and independent variables. Graph of y and graph of x. So for these things, left click y, double click, then say click view here and choose graph. It's not important to choose anyone. It is okay for basic type and line and symbol. So you see, the starting point is not 0. So there's a starting point. That means we have an intercept, a starting point. Intercept is B0, maybe B0 for a function. Say y is equal to B0 plus B1 x. Here B0 is a starting point, intercept, or you can see like that, intercept. And you see that the values is going up and down, light and hard pulse. So it's not going like that, starting from B0 and going, maybe goes up like that and maybe down. So this is not like that. So we said that we have no intercept. Here, the graphs shows that the intercept trend, but here we have no trend. So we have intercept, but no trend. Intercept, no trend. So again, click view and choose standard unit root test. And first of all, we are going to look on the level, and we find that we have only intercept, no trend. So we don't choose trend and intercept or none. If we have no intercept and no trend, we have to choose none. But here we have intercept and no trend. So we choose this one. And And for the leg length, it is automatic selection, but Schwarz information criteria and Akaike information criteria is the most valuable information criteria. You may choose each of them, then say OK. Now we see that our null hypothesis is H0 is Y has a unit root. Y has a unit root. And alternative hypothesis is Y is stationary. So let's look at the t-statistics and test critical values and the prop values. How can we look? How can we determine to reject H0 or admit H0? Now, you have to look at the t-statistics. You see it is 7.24. You have to look as an absolute value. And you see that it is bigger than 2.89. It's again in absolute value. So if this is like that, or if you look the prop values is 0.000. It's also smaller than 0.05. So if the case is like that, we reject H0. So we can think that it is stationary. If a variable is stationary on the level, this means it is integrated as zero, integrated on the zero level. This means I0. Y is I0. Now let's look the other one, the X one. And for the X, here, double left click and say view, again graph, and you see that again also X, the same value, has the same graph. So not the same values, but the same graph. How can we understand that they have not the same values? You may open double Y and X, and you may see the values as group. You see that as 1920, Y is 115, 55, and the other one is 1342. They are different. So let's open again X, and the graph is like that. Also, we have intercept. How can we understand the intercept? It's not starting from zero. You see here is zero, but it's starting like that. And again, we have a graph like heart pulse. So we have intercept and no trend for X values. So let's look to unit root results. Again, we look on the level and we choose intercept, but no trend. Again, leg length is used by Akaike information criteria. And finally, if we look to t-stat, what is t-stat here? In absolute value, minus 845 and bigger than minus 289. And we have also prop values. Prop values are smaller than 0.05. What does it mean? This means reject I0. And again, you may see that on the use view, it says that null hypothesis is X has a unit root. And if we reject this one, alternative one says X is stationary. we look on the level. So if X is stationary on the level, stationary on the level, this means X is I0 again. Finally, we have Y I0 and X I0. Let's write it again. Y I0 and X I0. If we have two I0 variable, you may remember from the other last video, the funny one, I said that if we have two I0 values, so we can either do ordinary least square or vector autoregressive models. Now, today we are going to do this one, ordinary least square. How can we do this method? How can we use this method? First of all, choose dependent variable, then press Control, here, dependent variable, then Control from your keyboard, then choose independent variable or variables. If you have the other ones, also you may choose the other one. Now press Control and choose X, then right click and open as equation. You may also reorder your equation, yxc or ycx. Cx means your equation is like that. Y is equal to b0 plus b1x. This means constant. If we write and reorder the equation on the EViews file, I write the C between y and x. So this means y is here, C is here, and x is here. This is the ordering on the EViews file. So we choose here ls, least square method, then say OK. Finally, you can see from the EViews file, our dependent variable is y. Our sample is starting from 1920 and up to 2019. So how can we find our number of observation? You can see it is 19, but don't forget to add 1. So we have 100 observation totally. Now our coefficients here, y is dependent variable, and we make clear and see easily. Here, y is equal to 32.87 plus 0.10x, and in normal parentheses, we write the standard errors, and again for the x1 is 0.005, and in brackets we write the t-stat values for the x and constant value. So how can we understand that these are statistically significant? We have this null hypothesis and alternative hypothesis for the values. What does the null hypothesis here? Say b is equal to 0 and b is different from 0. This means b is statistically significant, insignificant, and this means b is statistically significant. Yeah, you find a number. What you find? You find 0.10. So you want that your number is a true one. So this one says B is different from 0. So 0.10 also is different from 0. This means B is statistically significant if you find this one. So again, remember that T stat value, if T stat value is bigger than T critical values, or prop values are smaller than 0.05, we reject at 0. Is it like that? Yes. Again, 18 is bigger than our critical values. They are not written here, but you may find from your econometrics books the critical value for T-stat bigger than 30, it is 1.9. So if 18 is bigger than 1.9, or let's look our prop values. Prop values is 0.000 for the X. So it is smaller than 0.05. So we reject as 0. What does it mean? Our B is statistically significant. Okay, we find that our coefficient of X is statistically significant. Again, for the coefficient of constant value, you may look at 3, our T stat values, again bigger than T is bigger than 1.9, or our prop values for the C is 0.0028, and again smaller than 0.05. So again, we reject as 0, null hypothesis, reject. So finally, again, this one also statistically significant. So we can use this ordinary least square equation totally. So also we can look the F statistics. And so what does it mean? We individually look the constant value and the X values coefficient. But if you want to look the totally the equation, so we can look the F statistics, prob of F statistics. Also, you see that probability of F statistics is also 0.005000. So this means, again, you have a statistically significant model, totally statistically significant. And finally, we may look the R square values. R square means determination of coefficient. What does it mean? We have here, you see that R square is equal to 0.76. This means X explain the Y. This means independent variable explains the dependent variable. Explains the dependent variable as 76%. So R square means like that. Where is the other 0. Sorry, I couldn't write again. 0.24 part. This is the error term. For our equation. You may understand from the equation by writing like that, B0 plus B1x and E. This is the error term. So R square says this part, X explains the Y as 76%, and also we have 24% here. And this is the end of our lecture today, and thank you for your listening. Hope to see the other English lectures on this playing list. See you.